In this video, we are going to walk through the solution for a practice problem looking at percent composition, or sorry, with looking at the atomic mass of lithium and using that. So we're told that lithium has an atomic mass of 8.49 AMU. So that's giving us this atomic mass here that we find on the periodic table. Now we know it's composed of two isotopes, lithium-6 with an atomic mass of 6.015 atomic mass units, and lithium-7 with a mass of 7.016. The question is, what is the percent abundance of that lithium-7? So the thing that we don't know in this equation is we don't know the fraction of the isotope. So let's actually make that a different color. And we do know the mass of the isotopes, and we know the atomic mass. So if we were going to write this out, we really need to have two equations. So we're told that there's only two naturally occurring isotopes. So that means that 100% of my lithium will equal lithium-6 and lithium-7, the percent, right? So if I convert these percentages, so instead of it being 60% or 70% to fractions, I would divide everything by 100. And that would mean that I would have 1 is equal to that percent divided by 100. So that fraction of lithium-6 plus the fraction of lithium-7. We could set this up as x in terms of x and y as well. We could do 1 is equal to y plus x, where y is equal to that lithium-6 fraction and x is equal to the lithium-7 fraction. I could rearrange then and say 1 minus x is equal to y, or if you prefer keeping the lithium-6 and lithium-7 designations, 1 minus the lithium-7 fraction is equal to the lithium-6 fraction. So now I can use these here in this portion of the equation. So let's write this out. So the atomic mass is 6.94 atomic mass units. That's going to be equal to the fraction of one isotope times its mass, and then plus the fraction of the other one times its mass. So I'm going to have my, let's do lithium-6 first. The fraction of lithium-6, which would be y, or lithium-6, times the mass of my isotope for lithium-6, which is 6.015 atomic mass units. And that would be plus my x times my mass of lithium-7, which is going to be 7.016. And so now I have an equation, but I have two variables. So I'm going to use this right here to substitute. So instead of y, I'm going to do 1 minus x. So I'll have 6.94 is equal to 1 minus x times 6.015 plus x times 7.016. So I'm going to distribute this 6 out to both of these and start solving this equation for x. This is my goal. And what I'm going to find is that, let's go, an intermediary step is going to be equal to overall my negative 6.015x plus 6.015 plus 7.016x. Solving further, I'm going to get to 0.925 is equal to 1.001x, and 0.924 is equal to x. And remember, x is my lithium-7 fraction. So I found it. That's it. And that means, if I'm thinking about this in terms of percentages, that I have a 92.4% abundance of lithium-7 isotope of all my lithium that occurs naturally on the planet.